Greetings again everyone, welcome back to my channel. Here we are going to solve x in this equation where we have x to the power of x is equal to 5. Now you might want to save this video for future reference. You may also check out my Math Olympiad playlist to see how to solve other algebraic exponential equations like these ones. Now I also want to share that for these types of equations, they are not usually solvable by normal algebraic methods. However, just by looking at our equation, we already can arrive at our solution. Given that 2 squared equals 4 and 3 cubes equals 27, it's obvious that our solution for x is 2 point something. Let us look at how to solve our equation. We have x to the power of x equals 5. We start by taking the natural log of both sides of this equation. So we have ln x to the power of x equals ln 5. And now looking at our equation, we can simplify this by taking ln x to the power of x, applying this logarithm rule where we have ln a to the power of b. This can be simplified as b times ln a. So this means that we're going to write ln x to the power of x in the form of b times ln a. So therefore we're going to have x times ln x equals ln 5. Now as we move on to solving our equation, I did start by saying that these types of equation cannot be solved by using normal algebraic method. So from here I'll be introducing the type of method that we'll be using to solve this equation, and it is called the Lambert W function. Now this method is used to solve equations where the variable is in the base and also in the power. How this function works is that where we have an expression, we have a times e to the power of a. If we have this expression and we apply a w function to this expression, the result is a. So what we do is that this expression here, we have to turn our equation to have this expression here. So we start to write our equation in the form of a times e to the power of a by taking our x and writing it in the form of e. This is done by having e to the power of ln x. Now what's happening here is that ln actually cancels out our e, leaving us with x. In theory, ln is natural log where the base of the log is e. So we have e to the power of log base e of x, where the base e and the e here are just going to give us the value of x. So this means that e to the power of ln x gives us x. So this is what we're going to do. We're going to write x in terms of e into our equation. So then from here we say e to the power of ln x times ln x is equal to ln 5. Now if you like my video so far, you can give me a thumbs up, and if you want to see more of my videos, you can always subscribe to my channel. Now let us rearrange what we actually have here. We have ln x and we are multiplying this by e to the power of ln x, and we say that this is equal to ln 5. Now if you're looking carefully, you see here, we can say that here is a, we are multiplying this by e, and here is the same value as a. So we actually have a times e to the power of a. And if we apply a w function to this expression, the result is a. So what we're saying here, we can bracket both sides and apply a w function of both expressions. And as we say, applying a w function to an expression as a times e to the power of a, the result is a, which is ln x. So this means that we have ln x equals w of ln 5. Now from here we can apply the inverse function of ln, so that x is equal to e to the power of w of ln 5. Now I just want to add that you can also write your solution in this form, so that e to the power of w of x, and this is equal to x over w of x. So writing in this form, we'd have x is equal to ln 5. As we know that x here in this bracket, we know that that's actually ln 5. So we'd have x being ln 5, so we have ln 5 over w of ln 5. So from here we have x is equal to e to the power of w of ln 5, which w of ln 5, we can find this value by using a tool from Wolfram Alpha. So we can use Lambert W function on any expression using Wolfram Alpha. So we know that we have ln 5. So we want to find the value of W of ln 5. So we're just going to punch that in and find its value. So here we have the decimal approximation of W of ln 5. So this is 0.755827, and you can go on. So we're just going to round this off to about 5 decimal places. So we have x is equal to e to the power of 0.75583. We may also write this as x is equal to ln 5 over this value, so as 0.75583. We can now use our scientific calculator to find the value of e to the power of 0.75583. Let's see what that gives us. So here we have our value. We have 2.129378, and we can stop right there. At the starting of this video, it was concluded that x would be equal to 2 point something. And here we are now actually seeing that x is equal to 2 point something. And we're actually doing the actual working out of this solution. So x is equal to 2.129378. We can actually plug this value into our original equation to test the accuracy of this solution. So let us go ahead and just do that. So we have x to the power of x is equal to 5. And now having the solution for x, we can just rewrite x in this form. So we then have 2.129378 raised to the power of itself. So that's raised to the power of 2.129378. And you can just plug this into your calculator and test the result. And of course, the result is astonishing. This is equal to 5. Thanks again for staying tuned with me to the end of this video. I hope that this was very informative. If you like this video, please smash that like button, share and subscribe to this channel. Please stay tuned with my channel to see more of my math videos on how to solve complex solutions such as these ones. And until then, I'll see you again soon. Thanks again and take care.